Hello guys, this is AM and welcome to the channel. Welcome to another applicative algorithms videos. In this video, let's try to build an autocomplete tool which gathers knowledge from the Facebook messages that you can download from your Facebook account. I have downloaded mine, the results were interesting. It is very similar to the new Gmail feature which tries to predict the next word while composing the new email. As you may have noticed, it's very personalized to your context. I am amazed how it works and I would like to share the same with you. I hope you will like the video, and of course the source of the code is linked in the description below. Let's get started.
Okay, let's think about this first. The very basic implementation would be using a trie or a prefix tree data structure. Let me pull out an example of how prefix tree data structure might look like. So this is an example of a prefix tree. So these are the words, 7 odd words which are laid out in a prefix tree. And if you can see each word, this is a character prefix tree. We can apply the same algorithm or the same idea to the words as well. Now if you look at this point here, ROMONAE, so first word and the second word have most words same except the last one and the two words. So this is so we can decide to show both 1 and 2 when the user enters the word till Roman. So this is the basic idea of a trie or a prefix tree data structure, which is very intuitive in the first place, but it has its drawbacks. If you guessed the drawback as personalized or which word to show as the first word in the predictions, then you are right. Hence we need to look at another better approach. When you look back at the problem statement, it more or less looks like as if it is shouting as machine learning problem. Well, yes, we can employ one such language modeling technique called n-grams for this. N-grams are one of the sophisticated language modeling techniques where most of the companies, including Google, Autocomplete or Elasticsearch, uses this n-grams algorithm to predict the next words. Now, what is n-gram? The n is generally replaced by a unigram, trie or bigram. For us, in our example or the coding section of the video, we will be building a bigram model. So let's take example and see how these n-grams generally works. So here is a sentence: the bird is flying on the blue sky. These are the various trigrams that are formed. So we are considering all the sections of the substring of the sentence and we are dividing it in and calling them as trigrams. This sentence or list of trigrams are not efficient or useful unless we have the next word to the trigram. We form a mapping like this: trigram to the next word mapping. Now this is the final trigram and a next word mapping that we have formed. Now what if we have a huge corpus like this? Now as if we considered only one string, we got one word previously, but if we have multiple such sentences, we would be having an array of next words. Now this is a very important mapping or information about the data we have, where we can predict the next word based on the previous words. The previous words are nothing but the trigrams. Now what is the one information more that it is lacking would be, what if, let's say that we got a string, the bird is. Now the bird is, what should be the next word? It can be either flying, eating or sleeping. Now we can show all the three words or one word at random, but it will be more or less equivalent to the right data structure without having intuitive of which word which I can show first. So since we have only 3 words here, it's pretty easy to show all the 3 words and user can select any one of them that is useful for him. But what if, let's say Google has around millions and billions of sentences like this, and they just show top 10 results. So those top 10 probabilities or probability of next word is what we are interested in calculation. Now that is the second most important part of the n-gram. Now let's talk about how this probability is calculated. Now for the predictions part of the algorithm, first we have to calculate what is the probability of the each next word. Now let's say we have this toy corpus of these n sentences. So this is the conditional probability and we are conditioning over the sentence. These are the similar trigrams that we have formed in the previous example. Now how would we calculate this probability? Just count the number of times this is the house coming in the whole toy corpus and also divided by the number of times this is coming. Now if you see, there is only one time this is the house, the whole string is coming, and the number of times this is coming as 4. Now the probability of house given this is 1 by 4 times. So this is how we would be calculating the probability for a bigram model. I hope you have understood how the trigrams are created or how the n-grams are created. It's just simply moving the window given a sentence and forming all the n-grams. And once we have got the n-grams, we just create the probabilities of each next word. We will be having a probability set next words where given a word we can predict the next word based on the probability. The whole program is dependent on the data. So here the data for us at starting off to understand, we would be using the toy corpus similar to this, but the whole idea is to use the Facebook messages that we can easily download from Facebook and use them to create this language model and see what kind of predictions we would be getting or what kind of patterns we can find in our messages. So that I think that will be very interesting. So the whole code is given the Facebook reading from the Facebook messages. The whole complex part will be in the GitHub. The main idea for this video is to understand the core and the simplest example. Okay, let's get started and see how we can implement this n-gram model to predict the next word based on the previous words in a Go language. Let's get started. Let me create a new file called as main.go and let's write our whole code in this file now. So initially we need to write package main and initialize declare a method function and let's import fmt. Yeah, so let's just print one small. Now let's open our terminal here, and so I'm just opening up the internal terminal of VS Code. So let me just run main.go, right? Okay, so this is working. Now let's first need to get the text corpus. So let's say one method which returns the text corpus, right? So let's write the method here. So method which has like around 5-6 lines of sentences. Now let's call this method here and let's say corpus is get text corpus, and so here we will be getting. Now let's delete this. Now let's run it again. So we have got 6 sentences. Now as we have got the data ready, what should be the first step? The first step is constructing this map of word to trigram or bigram to the next word. Since we are constructing a bigram model, it will be 2 words. So for that sake, let's create a method called as create n-gram next word map. This method is taking a corpus and a window integer. So since this integer window is nothing but the window by which we have to move towards the right. And what about this bigram next value? Okay, initially we can replace this with in fact a string. So our map is nothing but a string to next word map, but this next word is an array, so we have multiple next words to the particular bigram. But as we have discussed, each word is associated with a probability. So since we need to hold for a probability for each word, we will be storing a structure instead of a just string value. So I'm just pasting this on the initial lines. So since we have got a map, so this method returns a map which is string mapped to a bigram next value. Now next what we are doing here is we are iterating through the corpus strings, and each string we are just printing out what is the current string we are looking at, and this method create map sentence that we have to implement now deals with creating the map. Now let's first write the declaration part of the method. Now this declaration ngram n will be for us it will be 2, and this is the current map. So every time the map will be updated by new values in the string, and this corpus is the whole data. The first would be we need to split the words into multiple array of words. So the first thing will be splitting the words into array of words. For that sake, we are using a library or inbuilt library that is provided called as strings. So let's import it. Import strings. Awesome. Now since we have strings, we can use multiple methods that are available. So these split words, so since we have multiple split words here, so it is nothing but each word, the word, is, and everything is split into each separate words. Since we have that, we just have to loop through each word. The current bigram string will be the current word. So since bigram is a 2 words, first it is mapping of one word to the next word, and the next word will be considered later on. The first current word will be the first word. So for example, it is starting off, it will be the, or next it will be bird, each word. So for the purpose, we will print out the current string as this, and then then after finding out the current word, we have to see what is the mapping to this current word, whether do we have any mapping to it. So this mapping, right? So the whole mapping is this one. So do we have this mapping? Initially it would be 0, that means no words will be there. So we will be finding out like this. So the next words will give us the map, but first we have to check if we have even formed the array or not. So for that we'll just do a if condition to find out the length of the next words, which is nothing but this array. So this array, if it is not there, we are creating we are making a slice here with the structure bigram next value. Bigram next value is nothing but word and a probability. So since we are creating the slice, we need to insert the new next word inside the particular slice for the current mapping. So let me create one structure with the values as empty string and probability as 0. Then we need to consider the next word to the current word. So the next word will be this one. So we are automatically updating it to the next word here. But what if we have reached the end of the string? That means we have to say that we have terminated the string. So to account that, we will actually use the if condition here just to check if we have reached the end of the loop. We will say the next word will be the terminating string. So we will further, for while prediction, we will check on this terminating a word has hash. It can be anything. I have chosen it as hash, and whenever we have reached the hash, we are done with our predictions. And so we have created the word, but we did not yet create the probability for the words. So calculate the probability for next word. So since we first want to try out and see if this mapping is correctly created, let's put this calculation part on hold and let's move further. For now, all the words will have the same probability, that is 0. Now it's time to add the next word to the slice. But before we add it to the slice, we have to check if the current word or the next word is already in the slice or not. If it is not, only then we are interested to add, or else no. So that's a simple check to do. So let's do that as well. So word already seen, we just looping to the all the next words. If the next word we have seen the word, then we are just breaking out the loop and saying if it is not seen, only then append it to the next words. So the next words is nothing but map. So this map, right? Till here we have successfully added the next word slice. Now we are left out by mapping these bigram to the next words. So this mapping is done by the current map, right? So we are just gonna add this line and we are mapping the next words to the current by string. Apart from the calculation of the probability, we are pretty much done with the method. So we are printing out the sentences and creating the map and returning the map. So let's take this map is equal to pass the corpus here and window will be 2, and yes, that's it. So we are getting the map. We'll just print out and check what will be the value, or it be bugs or something. To check that, we just have to run this, and yes, so I hope you are able to see. So this is the map that is created. So Jack build killed. So killed is another mapping which has the and 8. So if you can see here, killed is the right, and most words should be the right. So if you see the, it has house, malt, rat. So house, malt and rat, but the probabilities for everything is 0. The whole thing now would be calculating the probabilities. Now since we have our map ready, this is the first step of the basic implementation. Now let's go and calculate the probabilities for the each next word. So here is the place where we have commented out and where we have to implement the calculation part. Now to calculate the each word, we would use a method to calculate the probability of the each word. The next word is the structure where we have the word and the probability. First declare this function. Function will take the corpus, that is the whole data itself, because we need to count all the string or particular string in the whole data, and this is the n-gram string that we are looking at, and this is the word. So n-gram string will be the current string that we are looking at, and next word is the word that is consecutive to the n-gram. Now after taking that information where it is a combination of the n-gram and the word, so this for example will be like this plus is. So this will be the n-gram string and is will be the word. Now after having that, we need to calculate the probabilities. We know that we have to search for this and this is separately. So for that, let me have two variables and count variables I'm having to count, and now it's just looping through the sentences in each corpus data and counting the each word. Now for the probability sake, we have to divide this base count by the current string count. Now for that, so we have to just calculate it like this. So I'm using a float where I'm converting both of these to floating numbers, since we want the decimal points as well. And then after calculating the probability, I would just return P. Now this is the final probability calculation. The only one check that we are missing out is what if the current word is a terminating condition. So if the current word is a terminating condition, we would not like to calculate any probability. So in that case, we would just return probability as 0. Now this will be stored in the next word probability. Now let's see how this is working. Great. If you see, now each word has got some probability other than 0. Now let's test if that is the correct values or not. For example, the house. Now let's go to our text corpus and the house, right? How many times the is coming? 1, 2, 3, 4, and we have house for one time. So 1 by 4 is equal to 0.25. That is correct. Now for example, what about that? Then how many times that is coming? 1, 2, 3. 3 times that is coming, and Jack should be coming once. 1, yes. So 1 by 3 is 0.33. So I believe the probability calculation is coming correctly. Since we have now got the probabilities of each word and next word map, we have basically done with the language modeling part of the algorithm. Next step would be the predictions. What would be the prediction implementation? So prediction would take just map as well as the word. So this will be the map and that will be the word, and we will be getting the next predicted word, right? Now let's implement this prediction word. So this is the declaration part of the function where we are taking the map and input sentence as string. For the first step of the prediction would be splitting up this input sentence. Input sentence need not be one word as given for our sake. So let's first split them and use the words that we are required, that are necessary for us. Now we are splitting the words, we are finding out the length, and this is another sanity check to find out whether we have enough information to predict or not. After checking we have enough words in the sentence, we will take the last word of the particular sentence and we just need to find the maximum word. Now we need to find one word in this array which has the maximum probability. That is just simple. We just loop through the maximum possible words and assigning the value, that is the maximum probability value, to the structure maximum prob word. Since we have got the maximum probability value, the next step would be prediction. Now the prediction word would be just returning the maximum prob word and the word inside the word. So I believe that's all we require for prediction. Let's just print it and check it out. Now let's save it and run the program again. We are sending the word that and we are getting the word predicted as Jack. So if you look at the mapping, we have that, Jack, killed, and ate. So these are the three words that are mapped for that, but since all the three words have the same probability, we are getting the 0th index in the array. The best idea would be shuffling these words. I hope you have liked this video, and the whole implementation for the Facebook messages will be on the GitHub linked in the description below. I'll see you in the next one.